Okay, so I hope my screen is visible to everyone.
Yes, sir.
Okay, great. Thank you very much. So before we start, I'll just give a brief introduction about our company. So basically, our company name is TSM, the Safety Master Private Limited. So we are a traditional safety consulting company. We have our head office at Bhiwadi, Delhi NCR region. We have one more corporate office in Gurgaon. We have regional offices in Gujarat, Chennai, and Hyderabad locations. So basically, we are working with a motto that safer India, better world. So as you know, this webinar is also one more reason for working towards our vision, that is safer India, better world. So we are into consulting business. Apart from that consulting, we also have our products division, which is called as Book My Safety, and we also have our software division, which is called as Digitech. So in traditional, so this is basically our founder, Mr. Sanjeev Kumar Parekh. So this company has been started by him around 2016, and it's been a 10-year long journey. So we have around 800 clients all in and around India, and also out of India also. So basically, Hazop is hazard and operability. Hazard and operability means India, what are the hazards that are involved or present in your operations, and how we are going to identify it, what are the ways to identify it, and identifying the reason for those hazards, and what result that hazard will make or create in your process or your operations, and what are the safeguards that we have to prevent that hazard from happening, and whether the safeguard is adequate or not to handle or to prevent that hazard. If it is not adequate, what are the other things that we can implement to make it preventable? So this is basically what Hazop is all about. Sorry. So before we go into Hazop, we have to understand about we have to get a clarity about what is process safety, because Hazop is a process hazard analysis tool. So this will be coming under process safety management. So basically, as you all know, if you're from a process industry, then majorly in India, what we are doing is we are implementing process safety management according to OSHA's 14 elements. Apart from that, we also have 20 elements that was developed by CCP, Center for Chemical Process Safety Institution. So in India, what we are doing is we are following OSHA's 14 elements. It is a compressed form of CCPS's 20 elements basically. So in this course, what we are going to do is we'll be discussing about what is Hazop, what is the purpose of Hazop, what is the objective of our Hazop, and what are the terminologies involved in our Hazop strip. And we'll be discussing related to PNID also. We'll also be discussing how a team member should be consisting of, and we'll also discuss one case study related to Hazop strip. So this is how we are going to map our course. This webinar session. So I request all participants to be with me for the full session, so that it will be fruitful for you to get a knowledge about what is Hazop and how we can do a Hazop. So before we start, there is a very important thing to know about Hazop basically. So as we are talking about what is Hazop study, it is a process safety tool. When we are talking about process safety, we also have to discuss about occupational safety, because in process safety, we'll be focusing on the hazards or risks that are involved in a process, whereas occupational safety will be focusing on individual basis. Like we have identified the hazard. So for that hazard, how severe the hazard is, and what is the chances of that hazard to happen. Based on that, we'll be giving a number. So risk is nothing but severity into likelihood. Severity means how severe the impact can be, and likelihood is what is the chances of that hazard to happen. Hazop study, how you are going to do, from it will have a very detailed information about what are the things to do while doing a Hazop, what are the things to consider while you are doing a Hazop, what you should not do during a Hazop, what you should not be focusing on while you are doing a Hazop. So all the very detailed guide you can get while you are referring this IEC 61882. This is a British standard. And related to our Indian standard, it is required that liquid to be changed to a gaseous substance. Okay, so what I will do is I will have some plate heat exchangers or any condensation process equipment we have for making the liquid ammonia into a vapor state. For that, what we will be doing now, what is happening? There is a change of state. So in this case, what I will do is I have to make this as a 2 nodes only, because there is a change of state of the material. That is conversion of liquid to gas. In this case, then definitely you have to change the node. You have to consider the node till the liquid level, till the liquid state, and another node will be considered for the gaseous state. So this is one. So this is how you have to term your safeguards basically. So this you people are like, you people know like what is this thing, like this is the hazard. You have safeguards, barriers in between to prevent the incident from happening. Still, if you have any loopholes in your safeguards and the incident happens, you should be having a mitigative plan, like a plan inside your mind. What you have to do is take a paper, draw the flow chart, and with that flow chart you can start your hazard. I'm bringing a tanker to tank, and tank to reaction tank, that is your reactor. From reactor tank to your storage tank, final storage tank, from your final storage tank to another tanker for delivery of your material. This is how you have to create your entire preliminary Hazop. This is what we call it as preliminary Hazop. You should be having a process flow diagram or a process flow sheet with you. Also, what you should be having a description of the process. I'm describing the process. So and so material is coming from tanker and it is unloaded to the tanker there, storage tanks there, and from the storage tank the material is taken from the storage tank to the reactor, and from the reactor the reaction happens, and from the reactor it goes to the final storage tank, and from the final storage tank it goes to the tanker again for my end customer. So this description you give along with how much material it is coming, what is the capacity, what will be the capacity of the tank, how much things that is going to happen. All these things will be coming in the detailed part, because here we will be identifying only the preliminary things, major things that could happen, that could go wrong in your process. Then we will be moving on to the detailed Hazop. For doing a detailed Hazop, you should be having all these documents. What are those documents? Piping and instrument diagram, main thing. Without PNID, you won't be able to do the Hazop study. Next, you should be having your process calculations, how you are derived to this requirement. Another thing is process data sheets. Like if you are using any chemicals, you should be having the MSDS of that chemicals. So this, what is happening? Water is transferred from tank A to tank B using a pump. Okay, this is our node 1. Clear? So here we are considering the guide word as we are taking the parameter flow. Okay, so we are considering a guide word as no flow. No flow means deviation will be no flow of water from tank A to tank B. Okay, so this will be your deviation. Now tell me, like we have the things here as cause. Cause means, cause we have already discussed the reason for the deviation to happen. Here what we have considered the deviation as no flow of water from tank A to tank A. Why? The why part we have to write it in cause. Why? What are the possible reason? One can be your tank is empty. If the tank is empty, then there is no flow scenario is possible here. Correct? Then if the pump here fails, failure of pump is called as failure of pump can be another reason for no transfer of water to tank B. Correct? So these are the two scenarios that let us say if this is only consideration, if there is any manual valves are there, if someone like due to manual error kept that manual valve closed, then there is no chance of water transfer from tank A to tank B. Correct? So these are the reasons. What we have to do is we have to list down the reasons. So that is what we will be calling it as cause. Cause means the reason why deviation occurs. For a deviation, there can be multiple causes. Just like we have defined here, we have almost defined 3 to 4 causes. One is the tank empty, another one is failure of pump, another one is if there is any manual valves between the line, then that is also possible. So we have defined 3 causes basically. Now moving on, we'll be discussing on what is consequence. Consequence is the result. Okay, so basically what is the result of that deviation? If no flow is happening, what are the reasons? For each cause we have to write the consequence. That is a requirement. We should not be writing making the consequence as one. For each cause you have to give a consequence. Now moving on to the likelihood part. Likelihood part means what is the chances of happening. Chances of happening means if it is rare or if it is almost certain. Okay, rare means the event can happen more than 100 years once, and that is rare. If it is 10 to 100 years, then it is unlikely. If it is between 1 to 10 years, then it is possible to happen. If it is happening 1 or 2 times in a year, then it is called as likely. If it is happening more than 2 times, then you can term it as almost certain. So based on this, we'll be doing the risk assessment for the identified cause or consequence in our system for the identified node. Okay. So what will be the risk? Let us say I have identified the consequence as 3 and my likelihood as 4. So 3, here 4. So 3 and 4 means 12, which means my risk level is 12. Okay. Similarly, if my risk level is 4, but my likelihood of happening is 2. So 4 into 2, that is 8. So that my risk level is 8. So this is how we'll be doing the risk calculation. Clear? I hope everyone is clear about this risk calculation part. Now moving on. This is one more thing, process safety risk assessment. What is process safety risk assessment? While you're doing a process safety risk assessment, so here you can just see like how I have done my Hazop. Next to what? That will be the question, right? Why we are doing the Hazop? If I did my Hazop, what is the next? So for this, we have this intimation here. One is that the base level, the basic risk assessment will be your hazard identification. With your hazard identification, here what you can do is you can identify the hazards basically and evaluate, reduce, all these things can be done in your HERA. Whereas Hazop will be focusing on process deviations and whatever the safeguards that we have in our system. So Hazop is done. Okay, that is detailed risk analysis. Then once you do the Hazop, we'll be moving to LOPA. LOPA is nothing but layer of protection analysis. That is called as layer of protection analysis. LOPA in the plant. So that is what we are putting it as a rules here. So this, if you can follow these things, the same scenario won't be raising in your Hazop study sessions. This is very important. So keep in mind all these things that are required to carry out your Hazop study in an easier manner and in an effective manner basically. Okay. One more thing is that is also very important. No emotions, please, because this is what we usually see is that if we say some deviations in one department, what they take it personally. The things gets out of hands. They gets hurted emotionally. So all these things are only we have to keep that in mind. We are doing all these things for the process safety. So there should not be any emotions. It is only we are identifying how the process can be made into a safer one. So that will be the main motive of this thing. So we are only there to improve the safety. Nothing related to any blaming scenario or something like that. So this is also very important. You should be having while you are doing your Hazop study. Okay. Any questions?
No questions, sir. Me.
Okay. Nitesh, do you have any question?
Sir, what is the node-based PNID, sir?
Node-based PNID. So that is what we were talking about all this time. Like node-based PNID means you'll be having a PNID, and with that PNID, what we'll be doing is we'll be doing the segregation of nodes basically. Like I have already explained, like I have shown you one diagram. Tank 1, tank A and B. Between that we have a pump. So that will be reflected on your PNID. So we can take the node as either tank A to tank B, or we can segregate it or we can just separate it as tank A to pump as one node and pump to tank B as another node. So this is what we will call it as node PNID, node-based PNID.
Sir, can we consider the node on process step or only PNID?
Node marking shall be done on the PNID only.
Okay.
Yes.